Welcome to PowerHack Wednesdays. In today's episode, we're tackling the Billing CTF from TryHackMe Windows style. No Kali, no full Linux, just PowerShell WSL and pure hacker creativity. Let's get started. Before diving into the recon, I always start by setting up a simple notes file. Good documentation is just as important as good hacking. I quickly note down the target's IP address and main URL. This saves time later when jumping between terminals, browsers, and tools. Keeping clear, organized notes helps avoid mistakes and makes it way easier to write reports or blog posts later. Let's start with the basics. Recon. Good recon lays the foundation for the entire attack. We launch a full port scan using Nmap, running inside WSL, Windows subsystem for Linux. If you're not familiar with WSL, it's a built-in Windows feature that gives you a real Linux environment, right inside Windows without needing a heavy virtual machine. Think of it as having Linux power under the hood of your Windows setup. You can run Linux tools like Nmap, Gobuster, Python, and more seamlessly without ever leaving your Windows desktop. It's perfect for ethical hackers who want the best of both worlds: Windows flexibility and Linux hacking power. That's why I use it in all my PowerHack walkthroughs. While the scan is running, you can take the opportunity to do some manual recon. The results? For interesting open ports, SSH, a web server, MariaDB, and an asterisk call manager. This is a good idea to include in your notes. After spotting a web server running on port 80, our next move is to start digging beneath the surface. What you see in a browser is never the full story. We fire up Gobuster, a fast and powerful tool that brute forces hidden directories and files on web servers. Directory enumeration is a critical step in web hacking. It helps uncover admin panels, backup files, development logs, forgotten scripts, stuff that developers never meant for you to find. Here, I'm using a common word list and cranking up the threads to 50 for speed. Just remember, in real-world pentaists, you might need to throttle it down not to overwhelm the server. As the scan rolls, we start seeing some really interesting finds: /license, /archive, /fpdf, /lib, /resources, and most importantly, readme.md. README files can be goldmines. They often reveal the exact software version or even default credentials. Let's check it out. Opening the README shows that we're dealing with MagnusBilling version 7. That little discovery will set the stage for the next phase: vulnerability hunting. Now that we know the application is MagnusBilling version 7, it's time to find out if it has any known vulnerabilities. Instead of manually Googling around, I automate the process using my PowerHack CVE script. This script checks major vulnerability databases and exports the results to a clean HTML report. Why is this step important? In real-world hacking and in bug bounties, speed matters. Finding public vulnerabilities quickly can make or break a successful exploitation. And there it is. CVE 2023-30258. A juicy, unauthenticated command injection affecting MagnusBilling versions 6 and 7. Command injection is a heavy hitter. It means if the server takes unsanitized input and directly executes it, we can run our own system commands. No login needed. No account required. Just pure, direct control if the exploit works. Now that we've found our weakness, it's time to move in for the attack. Now that we know MagnusBilling is vulnerable to command injection, it's time to test if this specific server is actually exploitable. I'm going to send a simple sleep command through the vulnerable endpoint /billing/lib/icepay/icepay.php. Here's what's happening. If the server accepts the payload and actually runs sleep 2, there will be a noticeable delay before it responds. That delay is a signal that our commands are getting executed. If there's no delay, it means the input was probably sanitized or blocked. But if we get that 2-second pause, that's green light confirmation. This endpoint is wide open for exploitation. Now that we've confirmed execution, it's time to move beyond basic tests and push for full system access. Now that we know we have command execution, it's time to turn that into something more powerful: a reverse shell. A reverse shell means we trick the server into connecting back to us, giving us interactive control over its command line. Then, we trigger the payload by sending it to the vulnerable endpoint. If everything works, the server will open a connection back to us, and we'll catch it with our Ncat listener. But right now, the shell is a little rough. No colors, weird formatting, missing terminal features. To fix that, we use a Python one-liner to spawn a proper interactive TTY. Now we have a clean, stable shell, ready to start digging for flags and escalating privileges. Time to look for the first flag. We head into /home/Magnus and spot user.txt. Next step is to level up. We want root access. Privilege escalation is all about finding a weakness that lets a lower privileged user take full control of the system. I start by checking what commands the current user is allowed to run with sudo. Result shows permission to run /usr/bin/fail2ban, client without a password. And here's the jackpot. Our user can run fail2ban, client with sudo, without needing a password. So instead of blocking an IP, we tell fail2ban to set the SUID bit on /bin/bash. This will allow anyone running bash to automatically get root privileges. Next, we trigger the custom action by simulating a ban against a fake IP. Now /bin/bash has the SUID bit set, meaning the bash binary will inherit root privileges when executed. Finally, we spawn a new shell using the p option, telling bash to preserve elevated privileges. And just like that, we move from a restricted user shell to a full root shell. Game over. Now that we have a root-level shell, let's make it even cleaner and more stable. This Python one-liner spawns a fully interactive bash shell, setting both the user ID and group ID to root. This guarantees that every command we run stays 100% root level, without weird permission glitches. Now that we're fully stable, it's time to grab the final flag. Inside /root, we spot root.txt, the file we've been hunting since the start. And finally, we open it up and capture the root flag. Challenge complete. From recon to shell to privilege escalation, all done straight from Windows. That's the PowerHack way. Remember, this entire hack was done without ever leaving Windows. That's the PowerHack way. Thanks for hacking along. If you enjoyed this walkthrough, smash that like button, subscribe for weekly Windows hacking content, and check out my blog for more PowerHack guides. Until next time, keep hacking smart, stay curious, and hack from anywhere. PowerHack out.